Hello and welcome everyone. My name is Christian Hernandez Blick, head of program here at Interspecies Internet, and it's my pleasure to welcome all of you on behalf of the trustees and the organization to another Interspecies Conversations lecture. As many of you already know, Interspecies Conversations is a monthly online lecture series where leading thinkers share ideas and research that deepens our understanding of animal communication and cognition, often highlighting related insights into the behavior, conservation, and welfare of non-human species. We aim to platform emerging discoveries and host open discussions where the community can join the conversation with questions and feedback. If you enjoyed today's talk, please consider donating to Interspecies Internet to help support our programming, events, and other projects and activities. You can find a donation link on our website, interspecies.io, as well as in the video descriptions on our YouTube channel. Today, we're delighted to be joined by Clara Mancini, who will be presenting her talk, Why We Need to Design Technology for and with Animals. Clara Mancini is a professor of animal-computer interaction and founding head of the Animal-Computer Interaction Laboratory in the School of Computing and Communications at the Open University, UK. Her work investigates the interaction between animals and technology and the nexus between technology, animal well-being and justice, and human-animal relations. Her research spans the theory, methodology, practice, and ethics of designing animal-centered interactive systems for and with animals. Mancini's work has been published in leading peer-reviewed venues for computing, interaction design, animal-computer interaction, animal behavior, and welfare, and has appeared in international print and broadcast media. She has lectured and refereed worldwide, promoting animal-centered research and design for a multi-species world. In her talk, Clara will discuss the growing field of animal-computer interaction, or ACI, and its focus on the nexus between animals and technology from an animal-centered perspective, particularly in relation to the work of the Open University's Animal-Computer Interaction Laboratory. This lab was founded in 2011 to advance the art and science of designing animal-centered interactive systems by studying different kinds of interaction between animals and technology within their habitual contexts, by designing computer technology to improve animal welfare, support animal activities, and foster intra- and interspecies relationships, and by developing animal-centered approaches to design technology for and with animals as legitimate stakeholders and co-designers. She will discuss some of the projects her lab has worked on with cats, dogs, tigers, elephants, and parrots to illustrate the principles, methods, ethics, and politics informing the design of animal-centered interactive systems. Mancini will argue that beyond yielding design outcomes and processes that improve animals' lives and human-animal relations, ACI fosters attention, sensitivity, and empathy towards other beings, helping us reimagine multi-species relations for a more inclusive, equitable, and sustainable future. So with that, Clara, great to have you with us. And yeah, take it away.
Okay, thank you very much. I'm going to try and now share my presentation. And let's see if this works again. Can you see my first slides full screen?
Yes.
Excellent. Okay. Well, thank you so much for the introduction and for having me here. I'm afraid at the beginning I'm going to repeat a few of the things that you mentioned, Christian. So before I begin, the work that I'm going to present is the result of national and international collaborations with colleagues from academic institutions, charitable organizations, and industrial partners who are acknowledged along the way. So for millennia, much of the technology we have developed has advanced human interests by making it increasingly easier for us to outcompete, exploit, or simply use other animals. But with the advent of computing and with developments such as the Internet of Things and artificial intelligence, animals are being increasingly impacted by technologies whose design is all too often fundamentally human-centered. In contrast, the growing field of animal-computer interaction, or ACI for short, focuses on the nexus between animals and computing technology from an animal-centered perspective. As Christian was saying, in particular, the Open University's Animal-Computer Interaction Research Program was set up in 2011 on a mission to advance the art and science of designing animal-centered interactive systems for multi-species society. And as you mentioned, its aims are studying different kinds of interaction between animals and technology within their habitual contexts, designing computing technology that improves animals' welfare, that supports animals in their activities and fosters intra and interspecies relationships, and developing animal-centered approaches to design technology for and with animals as legitimate stakeholders and design contributors. So with the following examples, I will try to illustrate how we pursue these aims across species and contexts. So firstly, it is important to bear in mind how even the best intentioned uses of technology may impact animals and how to minimize these impacts. For example, this project investigated how to minimize the impact of wearable animal trackers by improving what we call wearability. Animals are often fitted with devices that track their movements, behaviors, and vital signs for conservation, research, and husbandry purposes. However, animal wearers, the primary stakeholders, have no control over their use. Devices can interfere with their body, for example, injuring or trapping them, and activities, for example, slowing them down or disrupting their camouflage, thus impacting their welfare and the quality of the recorded data. And existing guidelines for designing these devices still tend to be rather coarse and ad hoc. So we adapted values and principles informing the design of human wearables to develop a framework that could support a wearer-centered approach to the design of animal wearables. The framework is underpinned by the fundamental values of non-deleteriousness and minimization of effects, and by three design principles stating that the presence of tracking devices on the animal's body should ideally be imperceptible, or at least unobtrusive, or at the very least cognitively acceptable to them. All stakeholders should be considered, primarily the wearer, but also their significant others. That is, social relations such as mates and offspring, but also asocial relations such as predators and prey, and of course human users. Whereas biological characteristics, their activities, and their environment should all be considered, and all possible design variables, along with technical variables, should be exploited to maximize wearability. The example on the right suggests that when designing a tracker for red foxes, the device should not emit background noise that is within the hearing range of the fox, but also of her potential prey and predators. And this is just one aspect to consider. As a case study, Patrizia's behavioral observation of cats wearing different commercial GPS trackers showed poor wearability, even though these were marketed as cat-friendly. In contrast, her behavioral observation of the same cats wearing a tracker that she had redesigned using the same electronic components but applying the framework showed significantly better wearability. Now, collecting animal data in non-intrusive ways is particularly important when animals are asked to perform tasks that require concentration and precision, as is the case for biodetection dogs. So biodetection dogs are trained to recognize and indicate the presence of organic volatile compounds from diseased cells in biological samples, such as urine or sweat. But the signaling conventions they are trained to use for human convenience, such as sitting down in front of a positive sample, do not enable them to communicate all that they know. Because these conventions are binary signals that do not express nuances, such as a compound's concentration levels, and because they impose a translation overhead on the dogs that lowers the signal's reliability. So with medical detection dogs, the charity that pioneered biodetection with dogs, we wanted to find a way of accessing the dog's knowledge about the samples they sniff without them having to translate for us. We wanted to center the practice of biodetection on the dogs by shifting the translation burden onto the technology. So, hypothesizing that the dog's spontaneous response to the olfactory stimulus might be proportional to the stimulus presence and intensity, we designed a device that used pressure sensors to record the dog's interaction with the samples and capture their stimulus response. Early tests with solutions of amyl acetate, that is banana essence, showed some consistency in stimulus response between different dogs, with an interaction pattern emerging when the dogs encountered positive samples. And it seemed that there might be proportional variation in stimulus response depending on sample concentration. This suggests that the data may lend itself to machine learning approaches, and our preliminary application of neural networks to classify the dog's responses has already yielded promising results. So now medical detection dogs are currently using the latest version of the technology, which you see in this video, in their colorectal cancer detection project. The new apparatus captures both pressure and proximity data, which we are looking forward to analyzing very soon. We have finally received funding to do so. So while the aim of the previous project is to allow to focus on their work, allow dogs to focus on their work without taking any notice of the technology, in some cases dogs have to engage with technology to negotiate their way around their living and working environment. As a case in point, mobility assistance dogs trained to interact with various technologies on humans' behalf have to operate in human-centered environments that, from a dog perspective, contravene the most fundamental interaction design principles. This results in poor canine usability and user experience, impacting not only on the dog's training times and performance, but also on their welfare. So with Dogs for Good, a leading charity in the sector, we wanted to rethink the way in which ambient interfaces are designed to make them more accessible for dogs. We wanted to develop a portable kit of controls that could be retrofitted in the dog's living and working environment to make it easier for them to operate within it. We applied established design principles and usability goals according to the dog's specific circumstances, including dogs' sensory abilities, for example, their diachromatic vision, their cognitive abilities, for example, the way they categorize objects, their physical abilities, such as their snout's dexterity versus their limbs' strength, as the activities that they will need to conduct, for example, opening doors, switching lights, calling elevators, as well as the environment in which these activities need to take place, that is, the domestic and urban settings in which the dogs live and work. Our research shows that input devices designed according to these criteria make the dog's tasks much easier. For example, Louisa's comparison of our early controls against standard issue access controls for opening a motorized door showed improved usability based on parameters such as overall time to open the door, number of contact attempts made, and attempts necessary to activate the control. So here is a short video of my rescued dogs. So these are not special dogs, using the same controls after only a couple of short training sessions. So as I said, this is an early version of our controls. So Luisa further developed the design for our next generation of wireless cylindrical controls, testing different sizes as well as push pads with concave and convex profiles. She found that a control with a diameter of 120 millimeters and convex push pad performs best for dogs of different sizes. In particular, although the concave pads guided the dog's snout towards the center of the control, inviting a more precise interaction, the convex pads enable the dogs to activate the control from any angle. This provided more flexibility regarding their placement in the physical environment, which is critical for usability in small spaces. Now, following further improvements, our final wireless prototype, our dogosophy button as we call it, which we are now commercializing, allows dogs to easily control aspects of their environment, such as activating a range of domestic appliances. Now, beyond facilitating animals' functional interaction with their environment, the design challenge might sometimes be providing them with enriching user experiences. In particular, this project aimed to provide acoustic enrichment for elephants living in zoos. Overall user experience depends on the controls used to provide input into a system, for example, a button, on the output provided by the system in response, for example, a sound, and on the wider context in which the interaction occurs, for example, environmental noises that may interfere with sound output. Designing acoustic enrichment for elephants highlighted how the interaction needed to be intrinsically rewarding regardless of the outcome. The elephants showed great attention towards the sensory experience provided by the different input devices, which were objects of interest in themselves. This highlighted the importance of considering the animal's aesthetic preferences to design appealing interactions. Here are examples of prototypes that Fiona designed to enable elephants to control sound output, including wood and textile vibro buttons, knitted buttons, and copper radio buttons. And this is an elephant jukebox, which use copper radio buttons to trigger different pre-recorded sounds, and which was installed in the indoor habitat of 2 elephants residing at Noah's Ark Zoo in the UK. Sometimes, though, enrichment interventions in isolation are not sufficient, and a more holistic approach to the design of animal habitats is needed in order to meet their welfare priorities, as this project aimed to do. Many wild animals live in settings which lack the complexity and stimulation of the environment in which they evolved. For example, in the wild, tigers have extensive home ranges and spend their time patrolling their territory, foraging, hunting, or mating, whereas in zoos, they have limited space and everything is provided for them on a schedule. So they have little opportunity to engage in activities that in the wild would involve meaningful movement and constantly having to read the myriad signs of the land. However, research conducted with Care for the Rare shows that meaningful movement is a major welfare priority for tigers, as is in sensory engagement with the environment. So this was the starting point for designing a whole interactive environment to provide rescue tigers with such opportunities. The sanctuary where the tigers reside has created a new complex of interconnected outdoor enclosures. 3 of these are connected via a large building where our interactive system is installed. The building hosts an interactive maze consisting of 3 concentric irregular rings and an elevated central island. The rings are connected by 2 diametrically opposed gate systems, which will open and close to reconfigure the space and provide multiple routes to and from 5 different locations. 3 outdoor enclosures, 1 indoor den, and the elevation of the central island. As the tigers travel through the maze, olfactory, acoustic, and visual signals associated with different locations will guide them around the perimeters and through the gates. At specific points, the gates configuration will present the tigers with route options, giving them the opportunity to make choices to reach specific locations and the resources within them. Infrared sensors all around the ring's perimeters will allow the system to identify the tiger's location and trajectory and to dynamically adapt gate configurations and signals accordingly for a seamless journey. Here are some photos of the site under construction showing the interactive gates, the infrared sensor posts, the lights and the suspended gantry on which the speakers, lights, and scent emitters are mounted. We have almost finished installing the technology and are looking forward to working with the tigers themselves to adapt the functionalities of the system to their individual usability and user experience needs. But what if we could give animals tools to tell us what they do need and want? How should we design these tools? So this project addresses these questions based on Jennifer's work with cockatoos over the past decade. Millions of parrots live in captive conditions in which their complex cognitive and welfare needs are not adequately met by environments that are unsuited to their evolutionary characteristics and that severely limit their agency. To help address these challenges, Jennifer has taught a small group of cockatoos to use a speech board. This is a tablet-based application featuring menus and submenus of items such as pictures and drawings, representing objects and ideas that might be relevant for the birds, including food, games, places, and even affective states. She has leveraged associative learning rules to teach the birds the meaning of the different representations so they could use them to communicate with her in their daily life. We recently examined the interaction of one of the parrots, Ellie, with a speech board through the lens of Jacobson's communication model, which identifies 6 possible functions of communicative utterances, respectively inducing desired behavior in others, conveying affects, maintaining social relations, sharing observations about the environment, producing aesthetic expressions, and commenting about language itself. We found that Ellie's speech board selections map onto 4 of Jacobson's categories. These mostly had a conative function, being primarily requests for cognitive or environmental enrichment, secondarily requests for social interactions, and finally requests for resources such as food and beverages. A smaller proportion of selections had emotive function, including expressions of affective states such as contentment or discontent, and an even smaller proportion of selections had haptic function, akin to sort of chit-chat. Finally, very few selections had referential function, including observations on aspects of the environment. These findings make perfect sense considering that Ellie's caregiver is her proxy for interacting with relevant aspects of her environment, and hence the conative utterances, and also a key social component of her interspecies flock, and hence the emotive empathic utterances. So we also ran some tests to see whether Ellie's selections evidenced intentional communication. We found that she was persistent in requesting things when these were purposely denied to her, and she consistently refused things she was given instead of the things she had asked for. When she finally received what she wanted, she corroborated her original selections by either consuming requested items or engaging with the requested activities. When menus were randomly rearranged, she found her favorite items regardless of their placement. Now, in this short video from a menu featuring different treats, Ellie selects sunflower seeds, but is instead offered broccoli and then another kind of seed, both of which she refuses. When she is finally offered sunflower seeds, she consumes them.
How about some seed ball?
So this is still,
No? Okay.
she's eating the, still tasting and refusing the seed ball. So if you see now, she's closed that menu. She's just been given the sunflower seeds, so she is consuming those. So having closed the menu, she now opens her tablet picture gallery She searches for the sunflower seed thumbnail and then magnifies it and sits back, leaving it there for a human to find. So this work opens many interesting questions. What are the parrot's sense-making mechanisms at play here? Is it just associative learning and the resulting conventions, or do the parrots recognize iconic representations as such? And if so, what level of fidelity is required? What interface design, including items, representational arrangement, and categorization choices would best support parrots' functional communication? What design criteria are relevant for the birds? How could existing limitations of the medium be addressed to enable the birds easy and error-free interactions? We did see that they have some issues with the touch screen, for example. If we could answer all these questions, could this kind of tool become a reliable means for birds to self-report, at least for this particular species of bird? So we're currently investigating these questions, and the birds' active participation in the research is, of course, central. And indeed, a tenet of ACI is that whenever possible, designing for animals is best achieved by designing with them. And in this regard, the ethical and methodological perspective with which we approach the process is key. In other words, supporting animal-centered research and design requires an animal-centered ethical approach. So above and beyond existing regulations, which are largely inadequate from our perspective, our ethics framework is grounded in 4 key principles. Relevance, which requires working only with animals for whom the research is directly relevant and beneficial. Impartiality, which requires protecting all participants in virtue of their role rather than their characteristics, such as age, sex, species, or assumed levels of sentience. Welfare, which requires ensuring all participants' physical and psychological well-being at all times. And, crucially, consent, which needs to be obtained from all participants, including animals. Importantly, for us, animals' consent takes 2 complementary and equally necessary forms. Mediated consent, obtained from human guardians who know the animal well and understand the implications of their involvement, who have their best interests at heart and the legal authority to decide on their behalf, and contingent consent, provided by animal participants themselves, who must be allowed to continually assess the situation and choose what to do, whether and how to engage, while the appropriate monitoring of any manifestations of dissent should enable guardians to respond accordingly. Now, in a nutshell, doing animal-centered research and design implies respecting participants' autonomy and safeguarding their integrity by working in contexts that are habitual for the animal, being unobtrusive and undisruptive of their habitual activities, by giving animals control and space for expression, and using only positive forms of interaction. This approach is applied within an interaction design process that is quintessentially iterative and during which design requirements are elicited using various methods, design concepts are produced, selected designs are prototyped, and then evaluated to identify further requirements. This is an open-ended process of incremental orientation towards a perfect final outcome that may never be achieved, but that can be gradually approximated over several iterative cycles. It is in this context that animals' ethical involvement becomes participation as it informs the design process. For example, in this project, we were aiming to design an alarm to enable medical alert dogs, trained by medical detection dogs, to call for help in a crisis. Although these dogs consistently alert their assisted humans to upcoming critical medical episodes, their humans are not always able to respond in time and may become incapacitated, which leaves the dogs powerless and in distress. The dogs needed to interact with the alarm as autonomous users, so the interaction needed to be safe, efficient, easy to learn, and to remember. This particular design concept comprised an electronic module that would trigger a call to a phone line and a biteable tag for the dog to use as an input device connected to the electronic module by a trigger. But what should the tag be like? What should its size, shape, texture, or material be? What kind of trigger should connect it to the electronic module? Should the tag detach when pulled, or should it stay in place? How should the system give the dog feedback to let them know that they have successfully raised the alarm? To answer these questions, Charlotte used what we call quick and dirty prototyping to engage in sort of physical conversations with our canine users. She formulated a modular template for a canine alarm consisting of a tag for the dog to use as an input device, a block of wood in lieu of the alarm's electronic module, and the trigger connecting the two. In this way, she could quickly present canine participants with successive combinations of different tags and different triggers. This dialogue suggested that the dogs preferred a simple and tidy setup not to confuse them, a detachable tag that worked as a form of feedback, letting them know that they had completed the task, and customizable tag and trigger resistance depending on the dog's age, training stage, and personality. And here is an example of a canine user in action with a customized tag. For another example, we explored questions regarding animal participation by teaching my dog Zina to interact with the early versions of our dog-friendly controls, the ones you saw earlier, to open a small door and switch on a light. The coming short videos offer an example of how we take input and direction from our participants. So here we are already making progress with the training, which employs the luring method. To help Zina associate her touching the control with a reward, I place a treat on top of it. So whenever she goes for the treat, she simultaneously triggers the control, which soon establishes a consistent association between the two events. At the same time, this creates a strong bias towards snout interaction though. Now here, I am trying to persuade Zina to touch the larger yellow light switching control that is above the small door, which is a much more demanding task due to the control's height. She has done it a few times, but now she refuses to continue, sitting down and looking at me in a begging behavior instead. Now here, she still refuses to engage with the light switching control. I could offer her a higher value reward to persuade her, but keeping the reward constant tells us that there is an effort threshold that we should not pass. Instead, I ask her to touch the lower yellow door opening control. Despite the bias towards snout interaction that I had previously created, she chooses to use her paw. So it is clear that she understands what the task entails, but elects to do it in her own way. Whatever her reasons for doing so, she interprets the task and the action pattern required to complete it, and by rewarding her, I accept her interpretation. This has implications for design that will inform the next iteration cycle. For example, that the control needs to be located much lower, or better still, its height needs to be adjustable, that the pad needs to be sensitive enough to respond to snout interaction, which can be very light, and robust enough to withstand paw interaction, which can be very heavy, and that the pad's surface needs to be comfortable for a dog's delicate nose to touch, whilst also withstanding claw abrasion. Eventually, all this led to the final prototype that you saw earlier. Now, so far we have looked at technologies broadly designed to support animals with a focus on their needs. But what about situations in which the stakes for animals are higher? Is it possible to design animal-centered technology when designers operate within socioeconomic systems that are not necessarily animal-centered? Addressing this question requires dealing with the wider political implications of animal-centered design. This means being aware that design is an intrinsically political activity in which decisions are made that change the world and impact different constituencies. This inevitably raises issues of justice in general and of multi-species justice in particular, which we explored in this project. For this, we refer to Martha Nussbaum's political philosophy and to her capabilities approach, according to which animals are agents capable of dignified existence, with corresponding needs for flourishing and related goals they actively pursue to achieve capabilities to which they are morally entitled. The approach does not demand interspecies equality or the abolition of all instrumental relations with animals, but it does require the fulfillment of animals' capabilities to at least an adequate threshold as relevant to their species. It also supports respectful practices that are compatible with animals' capabilities and that develop their excellencies and promote their flourishing. The capabilities approach to multispecies justice provides a measure of animal-centeredness that could inform wider considerations when designing animal technology or when studying animals' interactions with technology. Here are some examples of questions that could help researchers assess the extent to which their work is animal-centered and thus conducive to multispecies justice. Now, additionally, among others, we proposed 3 design strategies to promote animal-centered design. Disruption involves questioning systems, norms, and practices that go against animals' basic capabilities and that designers would like to address. For example, Natalia and I questioned whether smart dairy farms of the future might breach animals' entitlement to privacy and non-exploitation. Entitlements which can be successfully argued for by using already existing jurisprudence. Reconfiguration involves redefining design frameworks whose current human-centric definition legitimizes the dismissal of animals' role in the design process or justifies design outcomes that discriminate against them. For example, UCNI proposed a multi-species framework for participatory design to account for animal agencies and interests in design processes and outcomes. Pollination involves seeking opportunities to enable animal-centered values to influence systems and practices which involve animals but which are not animal-centered, to help such systems evolve towards animal justice. For example, Eleanor and I have been exploring the extensibility of ACI's animal-centered research ethics to all animal research. We have developed an ethical review framework that integrates the principles of relevance, impartiality, welfare, and consent for the iterative refinement of any research activities involving animals. Now, one example of how these strategies could be applied is by reinterpreting governance ethical frameworks from a multi-species perspective to foreground impacts of emerging technologies on animals and raise animal-centered ethical concerns. For instance, what if we assessed smart farming systems against the principles underpinning European ethics guidelines for trustworthy artificial intelligence? The guidelines specify that designers of AI systems should pay particular attention to those who have historically been disadvantaged or are at risk of exclusion, and to situations which are characterized by asymmetries of power or information. A statement that perfectly describes the condition of farmed animals. Global governance bodies are also increasingly recognizing the interdependence of human, animal, and environmental well-being, and the inability of human-centric approaches to deliver sustainability. Arguably, an animal-centered perspective on the design, development, and deployment of computing technologies could support the pursuit of global sustainability agendas. For example, much animal-centered design is highly relevant to several of the United Nations Sustainable Development Goals. Consider, for example, the goal of good health and well-being. Animal-centered technology could foster beneficial human-animal relations, support animals who help humans, or improve animal welfare, reducing the risk of disease. Or consider life below water and life on land. Animal-centered technology could engage people in conservation activities, enhance conservation efforts, and reduce human-wildlife conflicts. Or consider sustainable cities and communities. Animal-centered technology could foster beneficial human-nature connections within urban environments and facilitate social inclusion by involving marginalized groups in urban wildlife custodianship. So, with this in mind, I would just like to end with a vision which tries to bring together some of the points discussed so far and which resulted from a collaboration exploring the role of technology such as artificial intelligence in the development of multi-species smart sustainable city as a matter of justice. Now, conceptually, smart sustainable cities are expected to integrate advanced information and communications technology within sustainable urban infrastructures. Digital sensing technologies, cloud computing infrastructures, middleware architectures, and wireless communication networks would all be used to monitor and analyze urban phenomena and to plan and manage access to resources and services in order to meet the environmental, economic, social, and cultural needs of their citizens with equity and inclusivity. But urbanization is increasingly encroaching on animals' habitats, and animals are moving into cities, which have an increasing role to play in biodiversity conservation. Thus, in order to be sustainable, smart cities need to acknowledge animal dwellers and meet their needs too. In other words, we argue that smart sustainable cities should enable animal dwellers equitably and inclusively to perceive, to make sense of, and to interact effectively with their urban surroundings as they pursue biologically relevant goals, including environmental goals such as building, inhabiting, and traversing structures, economic goals such as acquiring and managing resources, social goals such as forming and maintaining social groups, and cultural goals such as gaining and transmitting knowledge and skills. But how to determine what goals different species value and when these are adequately met? How to identify species to be considered and how to decide which species needs to prioritize? How to reconcile conflicting needs among species and compensate for lost opportunities? How to unambiguously communicate relevant possibilities to different species. This is where smart technology could really help, starting small, maybe with one species or a few in a location or two, and iteratively expanding to encompass entire urban ecosystems, using multimodal sensors to collect data on animals' presence, activity, and existing possibilities, and leveraging various capabilities of artificial intelligence to process and interpret data for identifying needs and trade-offs, to inform design solutions that mediate different species' needs, to select solutions that maximize benefit where most needed, and to communicate relevant possibilities to different species in a species-appropriate way. Imagine an ecologically and ethically responsible AI that redistributes control and benefits across all city dwellers. In conclusion, we have a responsibility to address the existential challenges that we have created and that now face our planet, so that it can sustain all earthly life into the future. While technology could play an important role in the pursuit of a sustainable future, this will arguably depend on whether we will be able to use it to develop more harmonious relations with the beings with whom we share our common home. In this regard, I suggest that ACI's animal-centered perspective on designing technology for and with animals could not only yield design outcomes and processes that improve animals' lives and human-animal relations, but arguably, and more importantly, it could produce ways of thinking and practices that are more attentive, sensitive, and empathetic towards other beings, helping us to meet the responsibility that arises from our ability to develop technology and from the power that technology gives us. This would provide us, I would suggest, with an opportunity to reconfigure multi-species relations and redefine our place in the world for a more inclusive, equitable, and sustainable future. Thank you.
Thank you so much, Clara, for that wonderful and stimulating presentation.
Would you like me to stop sharing? Sorry.
Oh, that's fine. Yeah, you could leave it up or stop sharing. It's up to you, really.
Okay, I'll stop sharing just in case.
Yeah, that's nice. We can see everyone's faces here. Yeah, thanks again for such a stimulating presentation. The vision of ACI that you present is fascinating and very wide ranging, and really inspiring. And there's a lot to consider here. So I think now we'll turn to questions and comments from the audience, and perhaps they have some thoughts to share on your research. So just before we open things up to discussion, I just want to remind everyone of the two ways that you can add your remarks, either using the chat function, selecting the chat icon on the bottom of the screen to post your questions, or if you'd like to ask questions on the call, to select the react icon, then the raise hand function, and I'll call upon people in sequence. And feel free to introduce yourself and say something about your background as well, if you'd like. Maybe as people gather their thoughts, I have a pretty general question. Maybe I can get things started with. So yeah, as I'm sure you and our community are well aware, there has been some interesting breakthroughs in the last few years using machine learning methods to study animal communication. And this has prompted discussion among scientists and technologists, ethicists, and the broader public about risks and opportunities presented by the possibility of developing technology to facilitate two-way communication between humans and other animals. And obviously, I think the field of ACI has a lot to contribute to this discussion. But I guess I'm wondering what you think are some of the most salient things that ACI can offer to this rapidly advancing area of research, particularly as it concerns how developments could be used to benefit or avoid harming the animals that are being studied.
Yeah. So there are two kinds of answers that I could give, two levels, if you like, two levels of answers. So for one thing, I would, I think one thing that gives me pause for thought with these AI approaches to deciphering effectively animal communication, and they're extremely valuable. But I think one thing to be careful of is that we don't confuse deciphering animal communication with understanding animals' experience. And the other thing is the role of intentionality in communication. So whether animals know that they are in a dialogue, some sort of dialogue, whether they are actually intentionally engaged in communication, or whether they are just being translated without them knowing. So these are things that are important to consider, and I would argue that the two approaches are complementary, and they ought to be kept in complement. So I was showing the work with biodetection dogs. So in that case, the application of machine learning, of AI, to the detection process I would say is very valuable. The dog is doing, we are trying to capture a spontaneous response from an animal, from the dogs, not necessarily, it's not necessarily the case that the dog wants to communicate something specific to us, even though they have been trained to communicate in a sort of binary way, for human convenience, of course. So in the case of the work with parrots, there is actually a focus on the animals intentionally engaging in an exchange, so in kind of engaging with their caregivers as a proxy to interact with the environment or to maintain a social relations that is part of the, that is essential for their daily life. These are social animals, and if they live with humans, that that's their social group. So I think that's one kind of answer. The other, and I think ACI in that regard, I think can help perhaps, is try and keep the focus on the animal's agency, fundamentally. The animal agency, the animal intentionality, the animal, and of course, the animal welfare, but to try and keep the whole, the endeavor animal-centered. So fundamentally, the key is what animals want and need in this context. Now, one thing that I mean, there are lots of things that I didn't have time to talk about. But one piece of work that we did was concerning animals, the issue of animal privacy. So all these sensors now all over in the environment are capturing lots of data about the animals without the animals knowing, which could potentially, as you sort of hinted, may pose a threat to the animal safety. And so we don't have their consent to do that. Now, we may think that this can be overridden and it doesn't matter, but it is nevertheless an ethical consideration that I think we should make. If animals knew that they were measured and monitored, let alone physical impacts, but would they agree to that? So we may think that this doesn't matter as a question, but I think that actually it would be, that's something that we ought to still bear in mind. We don't have necessarily permission to do whatever we want just because we can. And so this consideration, this being careful about these things applies also, I think, when we want to use AI and all this sort of sensory apparatus that goes with it to capture the data that then we want to process. That we need to consider that even if the answer in the end is no, we still need to do it, but because the benefits are greater than the risk. But keep asking the questions, I think is important. So those are some of the things that I would say, and as I said, complementing the different approaches, sort of deciphering animals as well as engaging them actively in their active participation, and also bearing in mind and always trying to come from an animal-centered perspective, always wondering what is that the animal would want, what is that is good for the animal, etc. Those would be in a nutshell, the things that I would say.
Wonderful. Thank you, for sharing your thoughts. On that, I'm going to read some questions out from the chat. So Wendy says, fascinating and detailed presentation. Thank you, Clara. I was wondering if you could elaborate on the risks inherent in improving the lives of exploited animals. So, for example, in factory farms that encourage humans to disregard the fundamental ethical issues of our use of other species.
Yeah, that's a really big one, and one that I personally struggle with. I am a vegan, and I have, on a personal basis, I hope you don't mind me sharing this, but on a personal basis, I have, I find it, sort of challenging to engage with these realities. But so, and I think this is a deeply, deeply personal personal issue. So as an ACI researcher, I have this dilemma. So do I refuse to engage with an industry that I struggle with? And so in theory, suppose that there weren't other people doing it. But, you know, if all ACI researchers refused, so in theory, then not much would change there. We wouldn't bring the benefits that we could potentially bring, the animal-centered perspective that we could potentially bring. Now, if I engage, it might be an endorsement of what things that happen in the industry, which could be problematic. And unfortunately, I cannot give an answer that is general, because this is a very personal thing. What I would say is what I was saying in part of my presentation regarding the wider consideration, the wider ethical and political considerations of animal-centered design. So these may end up being something different for different people, but the key is to ponder those questions. I was putting examples of questions that researchers could ask themselves, and also you know, strategies that could in the paper where we talk about this work. Actually, we have various things, not just those strategies, we have other considerations as well. So if anybody's interested, you can go and find much more detail in there. But so we try to provide tools for researchers to make their decisions in these situations, which are ethically challenging, I would say, depending on where one is standing. So that's sort of for the broader context. In any case, whatever your broader sort of view, when you do ACI research, I would say, and do say, we always, whether it is in a factory farm, whether it is in a zoo, whether it is in a home, we always abide by our ethics approach, ethics framework, which is that whatever happens to the animals outside of this research settings, we treat the animal just as we would treat any vulnerable human being. And according to the principles that I mentioned in the presentation. So relevance, impartiality, welfare, and consent. And this is really, to me, it seems really important. And so I don't, you know, I wish I had a univocal answer to this, but it is a dilemma. And yeah, my hope is that if we engage with practices that we may have difficult with, they will find, you know, ethically problematic, that we can bring a perspective that gradually improves the situation for animals. That's what my colleague and I, Eleonora Nannoni, have been trying to do with animal research. So we thought, what if we can bring our the framework, ACI ethics framework, into any research that is done with animals, whatever is done to the animals? Can we find a way of integrating those principles in the ethical review process so that we can improve? Again, we've written a few papers about this to show how this could be done, and we are planning to run some workshops to start doing some trials of these and see whether that. So that's what I was calling earlier pollination. So, you know, we may not be able to reconfigure everything that we would like to reconfigure, but we can pollinate, and as much as we can, and, you know, and sure, we should try at least.
Wendy, do you want to follow up?
Thank you, Clara. You actually answered my question, which is, do you hope that your your work actually brings to the attention of people who do engage in exploitive industries with animals, that it will make them actually more aware of the individuality and the cognition and the intelligence of the species they're exploiting. And you answered the question with the pollination. So thank you.
Yeah.
Yeah.
It's my hope. It's my, you know, I try. Yeah.
Thank you.
Thank you.
All right, Francine asks in the chat, how do you see, or if you see a relationship between your approach and preparing captive animals bred in conservation programs who are then reintroduced into their wild habitats?
So you say, sorry, I was trying to find it in the chat. Preparing,
Yeah, the question is, how do you see your approach preparing captive animals bred in conservation programs for
okay, preparing them for reintroduction into the. I mean, this is not necessarily an ACI kind of, you know, something that, well, it can, I suppose ACI could help with that, because you can, so if we think of the Tiger Project, call it Tiger, you know, the sort of the, that I sort of showed a bit about earlier. So if you imagine using a combination of landscaping, sort of say landscape design and technology embedded into it, to gradually habituate the animals, train, sort of teach the animals to deal with the challenges that they sort of, you know, the environment in which they are going to be reintroduced will present. So you can definitely take an approach similar to that of the that we took with the meaningful movement project, with, you know, with tigers, to prepare animals who are to be reintroduced. So you gradually make it, you could potentially create an environment that is reconfigurable in various ways, not just physically, but also in terms of sensory stimuli, signals of different things. And just as that was the, you know, in our interactive maze, it doesn't have to be a maze. It could be some other, you know, or sort of landscaping form. But the point is that the advantage of using interactive technology is that you can configure aspects of an environment to make it to go from really easy, where the animal has immediate access to certain resources, whatever they want and need, and then gradually make it a little bit more challenging in a way that is akin to what they are expected to then encounter in the environment in which they will be finally released. I don't know whether this answers the question, but that's what I think that's the approach that could be taken.
Wonderful. I'm going to read one more question from the chat, and then I'll get to you, Monica. I see your hands waiting patiently. Ronnie asks, I am curious about how access to technology can be made for aquatic animals. I wonder if you have any experience with those types of animals.
I've never worked with aquatic animals, not yet at least. But I think the similar approaches can be taken in, you know, the principles are always the same. Within an aquatic environment, obviously there are some technical constraints you have to take into account. You know, you need robust equipment that can tolerate water and water pressure, that sort of thing. But you can again implement an environmental design that provides relevant signals for the animals to attain relevant resources, so they can read their environments. The environments could be configurable in ways that are, again, relevant for the animal. is these things are conceptually, they're very possible. Obviously, there is an issue of cost with all these things. So that is a consideration. I don't know if have answered this question, but to me, the principles would be the same as they would be on land. And you could do very similar things, not similar in the sense that they are the same, because of course the environment is different and the species are different. So, but the approach to earlier when I was talking about designing the dog-friendly buttons, I was saying you have to consider the sensory characteristics of the animal, the physical, cognitive characteristics. You have to consider what activities they normally, in what kind of activities they engage in, what the characteristics of those activities are, what the characteristics of the environment in which the activities take place, and think other things that influence what the animals know or don't know, other actors in the context. You consider, or you examine your design context considering all these things, and that is what and you consider what the welfare priorities of the animal are, and that's what informs your design for that particular species. So for every species and for every particular context, even for the same species, you come up with a different solution, but the process that you go through is effectively the same for every situation.
Great. Yeah, Monica, do you want to go ahead?
Yes, thank you. First of all, thank you so much, Clara. That was a very fascinating presentation. It was very great, very informative.
Thank you.
Yes, of course. I work in communications in my local city government, and my question is, how do you navigate dealing with your local government to encourage the use of animal-friendly designs within cities?
It's very hard. And so in the UK at the moment, actually, I'll answer by reporting on something. In the UK at the moment, there is this big debate that has flared up. Traditionally, conservatives were the ones that were least animal friendly, and the Labour Party were the ones that were the more animal friendly. Now, the Conservatives lost the last elections and went out, and the Labour Party came with this huge majority so they could do whatever they want. And we were all expecting much more animal friendly sort of, so yeah, this is going to get a little better for animals now. But they started actually sort of talking about eliminating some of the protections that exist for animals. For example, they won a major new rail track that sort of has been on the cards for a long time, is to pass through an ancient forest inhabited by a very rare species of bats. And the government's approach was like, we can't worry about every single bat. So we'll have to go through here, and then the people who develop this structure, because they claim that a tunnel to protect bats from the passage of the train would cost 100 million pounds. I'm not sure how they got to that figure, but so you clearly see how, or whether this is just an excuse or something, or how can I say, as a signal to say that some of these, that really these animals are being deprioritized at a time when the budgets are really tight, where governments don't have enough funds to cover, or, to services that need to be covered, etc. So this is they now they want to say, well, somebody will pay those who do developments or new housing, or they want to build many more houses, for example, in the country. All of this is going to impact terribly on wildlife, and developers are expected to pay some money into some fund so that in some other place, some animal friendly environment can be preserved or created. So, and this is really problematic because, you know, it's a loss of, it's going almost back to considering conservation just from a species perspective, instead of also considering the individual, which it used to be the case. But, you know, in later years, actually, there was a realization that the two things are interconnected, and you need to consider individual welfare as well as species conservation. But the problem is, sorry, I made it too long, but the problem is that with these pressures, when budgetary pressures exist, animals are usually the ones to lose. And similarly in the farming context, if you can't show the farmer that you are making them money, that you are making the investment worthwhile, they will not do it. So is the argument at that point needs to be, like I was trying to mention when I was talking about sustainable development goals and animal-centered technology. So the argument, and we have to demonstrate that if we do something that is a benefit of the animal, that also benefits humans, and that humans want that because it makes their life better. And unfortunately, this is the argument that we have to make. And it's fair, even when I was saying earlier, improving the way animal research is conducted to make it more. You can't just say that, yes, people don't like to hurt animals for research purposes, but they think but it's necessary, etc. So if we can improve, that's better, but it mustn't cost more. And critically, it must improve the quality of the research. So these are the sort of arguments that we need to make at governance level, unfortunately, because our governance bodies are still fundamentally human centered, human focused. A colleague and I recently have started arguing, started proposing that actually for the implementation of human rights, we need to include also animals. We need to consider animals. And we try to propose this to the United Nations and see what they make of it. But it is unfortunately the case that we have to try and show how the benefiting animals also benefits humans for the time being, at least. But I think if we can get that through, maybe we can gradually sensitize more also governance bodies. Of course, that's at the top, but with on the ground, how can I say, on the grassroots, the ground level, amongst people, that's not all, or not necessarily the only option, because I think a lot more people than used to be care about animals. And so at some point, the demand from people of better treatment of animals can result in some in improvements or a change of perspective, if not necessarily a whole shift. Of course, again, when it comes to considering, do I want free range? Do I want organic? But does it cost more? And I don't have much in my wallet to buy food for my children. Animals are going to lose, unfortunately.
Thank you very much. That's very insightful. And I will try to continue fighting for the animals along with you. So thanks.
Thank you. Thank you.
Taking those challenges into consideration and maybe in the spirit of utopic thinking, Taylor in the chat says, "Thank you so much for the talk, Clara. I'd love to hear you put on your sci-fi hat and take us 50 or 100 years into the future. Supposing animals have rights and representation, what are some ways you envision technology being used to facilitate interspecies democracy?
Okay, interesting. So imagine that there is a bit of AI that is doing some translation, but there's got to be some that the animals engage directly and intentionally themselves. So some sort of tools that animals can use to express what they want, bearing in mind that that can be very, very different from what humans want. Also, we have to bear in mind that animals are not necessarily democratic. And so, do we want animals to be democratic, or do we accept the fact that they're not necessarily democratic? So that, you know, there is that's a question. But in terms of, maybe that's why I thought that, I think that's why in the smart cities sort of bit of the presentation, and with our colleagues, we were thinking, actually, what if we could envisage a benign AI that takes over humans, it takes over animals, takes over everybody. And the thing that we are most afraid of, you know, that AI is going to take over, take control away from us humans. So, but imagine if there is an AI that, you know, is going to manage everybody. And so the way, you know, instead of being like a vote, a specific vote, or on certain issues, which may or may not be of relevance to everybody, this technology can assess the needs of different species and somehow allocate resources and benefits and also burdens, you know, across you know, different species in a way that keeps a balance. Now this could be seen as some sort of democratic process, not run by humans or by, you know, or by any particular species of animal, but run by AI, just based on what species specific needs might be. But a world like this would be a world in which humans would have a much harder time. We wouldn't be able to do half of the things we do. We would have to really change this idea of what being happy, or, you know, being happy means, and we would not be able to live forever and have all the luxuries that we have, and you know, be the ones who are always cured, etc., etc. So this it would be a world that it would be much, you know, that much more equitable, but where humanity would need to shrink a lot. And so that's that. I think if it was possible in 100 years' time, I imagine that could be, you know, I don't know how utopian could be from a human point of view, how utopic from a human point of view, but that's the problem that's our problem, that we only think of utopia or dystopia from a human-centered perspective. And in fact, if we take a broader perspective, you know, it could be there's some for you know, that a proper utopia is not so utopic for humans, but it's not so utopic for anyone in particular, but it's sort of the best, or the best possible world. We live in a world, in a material world, that is finite, has finite resources, and where the expansion of one results in the contraction of the other, which is not a painless process. Is extinction, for example, is a painful process. There are individuals involved who suffer to the bitter end. And so, you know, these I do, yeah, I think I would probably, and I think I would trust an AI independent of humans more in, if we wanted a proper democratic, interspecies democratic process, then I would an AI controlled by humans, because I don't think we would allow to have a proper democratic interspecies democratic process if we are in control. I don't know if that answers the question. Sorry, it was a bit a crazy answer, but
No, that's wonderful. It's nice to have some freedom to speculate. Um, yeah, Jesse in the chat says, I currently teach visual design students at the university level. There's a growing focus in recent years among the students around addressing these complex issues within their research and work. I think you offered a lot of helpful methods that could be adapted to non-interactive design practices and research, but I'd love to hear how you imagine other design disciplines most effectively engaging to make positive impacts towards the ACI principles that you have highlighted. Is that something you can offer some of your thoughts on?
I'll do my best, Jess. So I think, again, these principles could apply um, to research in any research with animals in any context. They could apply to design of any kind. So if it is design that is, I don't know, urban design, or architecture, or landscape design, the principles are pretty much the same. Who is going to inhabit this space? Who are we welcoming with this design? Who are we excluding? What are the characteristics of those we want to welcome, we are going to allow, we're going, what are they, the capabilities that Martha Nussbaum talks about. So, how are we going to enable them to pursue these dwellers or whatever space, or whatever, to pursue those capabilities, or users of whatever product, that, and how, what are the activities that these individuals and species need to engage in order to pursue their goals, and what are the characteristics of the environment in which we expect them to do so. And then effectively, I would say, applying an iterative design process, like I was saying, that that is very typical, that is absolutely typical of interaction design, this iterative process, but it can be applied to any kind of design. You design something, you test it, you try, you see what you see how those involved, those concerned, respond, how they use it, how they interact with it, whether, even if it is not interactive technology. And then you, from the observations that you make, the responses that you get, you go back to the drawing board and you either refine the requirements that you had identified, or you realize that you need to come up with a whole different concept because that wasn't working. So the way to do it gradually, I was saying earlier, quick and dirty prototyping, that's a cheap way of doing. You can simulate sometimes solutions that are not, in inexpensive ways. There is a thought, though, there to bear in mind. So when you give I don't know if how many of you are familiar with the interaction design process, some of the methods, but there is something called, for example, interface sketch and Wizard of Oz. Wizard of Oz is a group of methods. Basically, it allows you to imitate the interactivity of a system. You are faking it, basically. So you could imagine you're designing a new app for the iPhone. You just draw on a piece of paper, lots of, iPhone shapes, and you draw the interface that you want, your buttons, your controls, you put it, and then you say, if the user touches this, here is the next screen, and it's also a drawing on paper. So you can do lots of that, and that's a form of quick and dirty prototyping, of low fidelity prototyping. And it's very common because you want to figure out the placement of the controls before you start to program them, because that would be more expensive. Pen and paper is very cheap. So now you can ask your human participants to pretend that that's the real thing. And the human can say, oh yeah, okay. And then you go through the interactive flow, and sort of give you some guys feedback. You can't do this with an animal, because especially certain depending especially on the species, because what you give an animal is the real thing. So it's, there is not that sense of, oh look, I'm giving you these now, but this is just just pretend. An animal would take a face value, a prototype, and do whatever they do with it. So you have to bear that in mind when Louisa was doing when she was doing the buttons, she developed some prototypes, and the dogs would just eat them, would just do it. It's just because, not eat them like swallow, but just take bites out of them, because there isn't that level of abstraction that allows an animal to say, okay, this is just the presents. I just, for this one, I need to focus on that, on this particular aspect. So you have to consider these when you do your low fidelity prototyping, but that doesn't mean you cannot do it. You just have to consider that you may need to do it in a way that is adapted to how the animal is likely to interpret what you give them. So that's but that you can do that for any design activity, whether it is interaction design or any other design activity that you are engaging in. I hope that answers the question.
Yeah, we're coming up on the end of our time here. So there's one last question I'll address in the chat. Pete just asked if you can suggest a reference for the idea of pollination.
Well, yes, I have, let me see. I can put it in the chat perhaps. It's in that, did I leave it on? Or I think I closed it. I'm going to pull it up. That's one of the papers that we wrote, the paper we wrote about animal-centered design, interaction design, animal-centered research and design. So that was in 2003. No, 2002. Yes, this is the one. I'm going to put the link in the chat. And the title of the paper was Politicizing Animal-Computer Interaction, an approach to political engagement with animal-centered design. So that's where we talk about, among other things, about pollination. Now, if you want another, let me, regarding pollination, I mentioned that with my colleague Eleonora Nannoni, we try to develop an ethical review framework for any animal research. I'm going to send you to the website that we have for the project. This one, that's the one. There. And on that one, we have, again, a few publications, and we talk about the ethics, the papers there refer to the ethics paper that I had written for the basic ACI ethical framework. But but that's referenced there, and that is also available in that database that I'll put it in the chat as well. And we give an example of how we could, basically this is an example of pollination. So let's see if I can find the other. Maybe it was 17. Let's say this one. So this is it. So we took the principles on this paper here and we elaborated them for animal research more broadly, and then we did the paper in which we developed how a small application framework, and another paper in which we showed how it can be integrated into the ethical review for any animal research. So, and that's an example of pollination, of what we mean by pollination.
Great, thank you so much. That's terrific.
Thank you for asking.
Yeah, and thank you for sharing those resources. Yeah, I think we got to wrap things up now.
Sure.
Yeah, thanks to everyone for the great discussion, and to Clara for sharing your work with us.
Thank you all so much for really interesting questions, and for having me and for listening to me.
It's been great. Yeah. For those listening, if you'd like to stay up to date with Clara's work, or if you're working at the intersection of AI and animal communication, and are interested in the ACI approach to co-designing technology with animals, and perhaps collaborating with Clara to develop tools that affirm the agency and autonomy of the animals being studied in this context. I'm going to post some links in the chat here to Clara's Google Scholar page, open university profile, and a publication repository. Yeah, so thank you once again to the Interspecies Internet community for your engagement and interest in our public programming. Also, if you'd like to learn more about our organization, stay up to date with our lecture schedule and other events, projects, and activities, or connect with a community of researchers and enthusiasts, then please follow us on social media, visit our YouTube channel, join our Slack, and subscribe to our newsletter. Our assistant, Carolina, I think just shared these links in the chat with you. So yeah, once again, on behalf of the Interspecies Internet, the trustees in our community, thank you, Clara, so much for the wonderful and fascinating talk.
Thank you so much. Thank you so much again for having me. It's been a pleasure.
Yeah, it's been, yeah, thank you everyone in attendance for, such a rich discussion. Yeah, we look forward to seeing everyone next month for another Interspecies Conversations event. Have a great rest of your weekend, everyone.
Thank you. Bye-bye.